Hi, this is Dr. Lehmann, and this is actually take two. I'm going to be recording this video to share with students in Psych 250, Data Analysis in Psychology. For this video, I realize that I do not have enough time to get through all the features, but I'm going to just focus on how to run the frequencies analysis in SPSS. And so you should see here that I have open the Jiminy Cricket file. This is the file that we worked through in class today, if you were there. And this file you can download from Canvas. So to run a frequency, you can find it in the drop-down. You click on Analyze, and then go to Descriptive Statistics, and then go to Frequencies. So we're also going to be going through a couple of others. Those will be found just below. We'll go through descriptives and explore later, but we're going to start off with frequencies. Now, I've already moved this over here, but I will move it back. You will want to select these two variables. Now, in your list, they may look a little bit different, because what I've done is if I right-click here, I could switch between variable labels and variable names. So the variable names are success pre and success post, but the labels are level of success before intervention and after intervention. So I'm going to stick with the variable names because they're a little shorter. And I'm going to move this over with this arrow. So this says to SPSS that these are the variables I want SPSS to conduct the frequency analysis. I'm also going to ask for something else. I'm going to click on statistics, and again, these will not be clicked at this point in yours. So I'm just unclicking them because I had already done this, but you will see that all of them are unclicked, and you can go ahead and click mean, median, standard deviation, minimum, maximum, skewness, and kurtosis. And so this means that during the frequency analysis, they will also be conducting these descriptives. So I'm gonna go ahead and click continue. And really that's all I need to do. I'm gonna click OK now. And so in the output window, this window here, you could see on the left, there's a log here. So I'm going to select everything. You can see this selects everything. The log says that this is the syntax, kind of the programming code to conduct what we just did. So you can do this by typing in this analysis. But the other things is that this is the bulk of the results, everything below here. So we have the title, the statistics. Now again, this is reported, this is printed out because we had asked during the frequency analysis for these descriptive statistics, mean, median, standard deviation, skewness, kurtosis, minimum, maximum. But they wouldn't normally be there on a frequency analysis. So you have to ask for it. Now, down below, this is the bulk of our analysis. This is what's most important for our purposes, for understanding the frequencies. And you could see here that this table has these numbers on the left. These numbers represent scores. So these are actual scores that are present in the data set. And the frequency refers to how many people have that score. So this only one person had a score of 23, but 14 people had a score of 39. Similarly, only 0.4% had a score of 23. Well, that's 1 in 250. And so that's what this percent refers to. Now, if we had some data that were missing, this would be different. Because we don't, it's not. So if we had some missing data, it might look a little bit bigger, but usually you could just skip this column. And then we have the cumulative percent. And the cumulative percent is the percentage of people who obtain that score or anything below it. So 5.6% obtain a 36 or lower score, and 50.4% obtain a score of 50 or below. And we have two variables. So this is for before the intervention, level of success, and then this is level of success after the intervention. And so I won't go over that again, but that is basically a walkthrough of the frequency analysis. Now, I'm going to go ahead and run the next one, which is, again, if you haven't figured out that you can do through, well, on Windows, there's the drop-down menus here or drop-down menus on the output, and they will both do the same thing. On Mac, it might look a little bit different, but I'm going to go ahead and go to Analyze, Descriptive Statistics, and then Descriptives. And what this is, well, we already calculated it when we did the frequencies, but this is a more straightforward way to obtain it. Descriptives, we can now ask for level of success before the intervention, and I'm pressing down Control, and I'm going to select level of success after intervention. And I'm going to move those over. We don't have to worry about options or any of these. I'm just going to go ahead and click OK. And so here you have a very straightforward set of descriptive statistics: minimum, maximum, mean, and standard deviation. Now, if I wanted to, I could go back to Analyze, click on Descriptive Statistics, click on Descriptives, and I could add on some more options. I didn't obtain skewness and kurtosis, so I can add those now. So I'm going to go ahead and do that and click Continue, and then click OK. And you'll see here now it includes the statistic for the skewness. So you're going to look here and you'll see the skewness is 0.047 for before the intervention and 0.315 for after the intervention. And the kurtosis is 0.227 and negative 0.351. And so you could go ahead and ignore the standard error for both of these for our purposes. The skewness and kurtosis, if you recall from class, need to be between -1 and 1 to call the distribution normally distributed. So in this case, we do have all these values are between -1 and 1. So this is negative 0.351. That's between it. And so we can say that both of these variables seem to be normally distributed, at least on a surface level. Now, if I wanted to, I didn't show this in class, but if I wanted to get rid of this because I realized I wanted to have skewness and kurtosis, and I don't have it here, I could go back here, and I could delete it right here because this is going to get rid of that. But if I wanted to get rid of everything, I could click the yellow and then delete, and now that has been removed. And I can also delete this log that did not include kurtosis and skewness, so I can delete the log as well. Now, I'm going to show you next the last analysis for this introduction, and that is Descriptive Statistics and Explore. So I'm going to click on that. And this is different because it actually separates a variable based on some grouping variable. So our grouping variable in this case is strategy for success. One group of 125 participants just wished on a star for 5 years and hoped for success. The other group of 125 participants worked hard for success. And so that is our factor. That is our independent variable, our cause. So this is the factor is a nominal variable that we think to be a cause. And then we have our dependent variable. So it says dependent list. We only have one that we're going to look at here. We're just going to look at after the intervention is over. So after it's over, can we tell differences between the two groups, those who wished upon the stars and those who worked hard? And while I'm at this, I'm going to, let's see here. No, there's not there. If I wanted to, I could add a histogram. Actually, I'm going to just go ahead and continue just with the default levels. So I'm going to go ahead and press OK. And you'll see here that, like I said, that we had a sample size of 125 within the Wish Upon a Star group and 125 in the hard work group. So that's 250 in total. None were missing. And so we have a total of 100% are present for each group. Now down here, we'll see descriptives. But this is explore descriptives. And so what it does is it actually groups together the two groups, Wish Upon a Star and hard work, and looks at the descriptives for just those participants. So just those 125, what was their mean, their median, variance, minimum, maximum, range, skewness, kurtosis, and then similarly for the hard work group, what's their mean, median, minimum, maximum, skewness, kurtosis. So you can see here that the mean for Wishing Upon a Star was 49.66, and the mean for the hard work group was 65.19. So clearly, the participants who were assigned to the hard work group were able to achieve more success than those who were in the Wish Upon a Star group. And so, so that provides evidence that working hard is more likely to lead to success than wishing upon a star. Now, if I keep going down, we could see here a stem and leaf plot. We won't do much of this in this class, but if you did that in your statistics class, you might be familiar with it. And then further down, you have a stem and whiskers plot. The nice thing about this plot is it helps you identify outliers. So generally, participants would perform, on average, a little less well when they wished upon a star than if they were in the hard work group. But we see here that there's some outliers. These two individuals, case 204 and case 229, were able to outperform the typical participants. So we'll talk about this box plot a little later, but you'll see that these two, any points that are outside of the box and whiskers, these are the whiskers here, are considered outliers. So for your homework, you would say, if a case is outside the whiskers, you would say this is an outlier and this is an outlier. Well, I hope that was helpful. Again, for the homework assignment, you'll actually, instead of doing these one at a time, after each of these, you will close the file. So I did all three at once. It's one file, but on your homework assignment, after you do the frequency, you'll close the output file. After you do the descriptives, you'll close the output file, and after the explore, you'll close that output file. And in fact, you do explore twice. So I'm not going to save this document for myself. So I'm going to click no, but make sure you click yes and save the file. And so I hope this is helpful for you all. Please let me know if you find it helpful. And I'm going to record one more video, and it's going to show you how to zip the files once they've been created. Okay, thank you.